Hello! In this video, we will show you how to recover data from RAID 0, RAID 1, RAID 5, and RAID 10 arrays configured on the LSI 3ware 9750 controller. You will learn what to do if the RAID array no longer appears in this PC, if an error occurs during the RAID array rebuild process, if the controller has failed, or if one or more drives have become unavailable. We will also explain how to recover files deleted using Shift-Delete, as well as how to restore data after formatting a disk or deleting partitions. In addition, we will demonstrate how to recover information after RAID configuration changes, loss of RAID configuration, or controller firmware failure. The demonstration will be performed in a Windows environment. However, the recovery process is similar for Linux and macOS. LSI 3ware 9750 Technical Specifications. The LSI 3ware 9750 is a hardware RAID controller that connects via PCIe 2.0 x8 and is equipped with mini-SAS SSF 8087 ports. It supports speeds of up to 6 gigabits per port and works with both SAS and SATA drives, including HDDs and SSDs. The controller supports RAID 0, RAID 1, RAID 5, and RAID 10 configurations. It's designed for building RAID arrays and ensuring reliable access to data. Before starting the recovery process, prepare a separate storage device for saving recovered files. Do not write any data to the drives from which information has been lost until the recovery process is complete. How to recover files from a working RAID. If you accidentally deleted files using Shift-Delete, emptied the recycle bin, formatted a disk, or modified RAID partitions while the array remains operational, use Hetman Partition Recovery. The program will detect the drive and allow you to recover data as long as it is visible in this PC. Launch the program and select the required RAID disk. Then choose the analysis type. Fast Scan is suitable for recovering files deleted using Shift-Delete or removed from the recycle bin. Full analysis should be used after formatting, file system changes, or partition operations. Once the scan is complete, click Finish and the program will display the found files. Open the required folder select the necessary items and click Recover. For convenience, Preview, Search, and Filtering features are available to help you quickly locate the required data. Connecting the drives. Before beginning the recovery process, disconnect the drives from the RAID controller and connect them directly to the motherboard. Be sure to label and number the drives to preserve their original order. This is critically important because the controller writes and reads data in a specific sequence. Changing the order when connecting the drives to another system may make it impossible to correctly reconstruct the RAID structure and file system. For RAID 5 recovery, one missing drive is acceptable. For example, 2 out of 3 drives are sufficient. For RAID 0, all drives must be present without exception. A direct connection through the motherboard's SATA ports is recommended. If this is not possible, USB to SATA adapters may be used, although they can affect stability during recovery. If a drive shows signs of instability, physical errors, or if there are not enough ports available to connect, create a disk image before starting the analysis. How to create a disk image. To create a disk image, use Hetman RAID recovery or Hetman Partition recovery. In the program, select the required drive, right-click it, and choose Save Disk. Then, select the option to create an image of the entire disk and click Next. In the Next window, choose to save the image to a hard drive and click Next again. Then, specify the destination folder and click Save. Always save the disk image to a separate storage device, different from the one being recovered. How to use a disk image. To start working with a disk image, it must first be mounted. Only after mounting will the program recognize it as a separate storage device and allow it to be analyzed. In the program, click Mount Disk, select Raw Disk Images, and click Next. In the window that opens, navigate to the folder containing the image, select it, and click Open. The image will then appear in the list of drives as a separate storage device and will be available for further work. Working with a disk image is fully equivalent to working with a physical drive, so you can choose whichever option is more convenient. Automatic RAID recovery. Hetman RAID recovery automatically detects the RAID structure even if the controller has failed, multiple drives have become unavailable, firmware errors have occurred, or the array rebuild process was interrupted. The program independently reconstructs the required parameters for correct data reading and quick access to lost information. The video demonstrates recovery using a RAID 5 array, but the program also correctly recognizes RAID 0, RAID 1, and RAID 10 arrays. To begin recovery, simply install and launch the utility. Immediately after startup, it will scan all connected drives. In the main window, select the automatically detected RAID array, which will be displayed as a single logical device based on the service information read from the drives. Next, run a fast scan for quick access to folders and files, or use full analysis if the file system has been damaged. After the scan is completed, review the discovered files. Select the required ones and click Recover to save them on a different storage device. Manual RAID reconstruction. Manual reconstruction in Hetman RAID recovery is used when automatic parameter detection is impossible, for example due to severe metadata corruption or deletion of the RAID configuration in BIOS after changing the RAID type or following a system failure. In such situations, the user manually recreates the array structure by specifying the necessary parameters in the RAID constructor. Launch RAID constructor. To successfully reconstruct the array manually, you must specify the key RAID parameters: array type, for example RAID 0 or RAID 5, disk order, and block size. If the original RAID creation parameters are unknown, use typical values. For the LSI 3ware 9750 controller, the write asynchronous block order is commonly used, along with standard block sizes of 16 kilobytes, 64 kilobytes, or 256 kilobytes. Add the drives that were part of the RAID array. After selecting the drives, correctly determine their sequence in the constructor table. If the original order is unknown, you may test different combinations. Change the drive positions and click Refresh until the preview window displays a valid file system structure. Once the correct configuration has been identified, click Add. The reconstructed array will appear in the main program window and will be ready for further work. The final stage is data analysis and recovery. It is recommended to start with a fast scan for quick file detection, and if the folder structure is damaged, perform a full analysis. After the scan is completed, select the required files and click Recover to save them. Now you know how to recover data from RAID 0, RAID 1, RAID 5, and RAID 10 arrays on an LSI 3ware 9750 controller. If you have encountered similar situations or still have questions, let us know in the comments section. Subscribe to the channel so you do not miss new data recovery guides and tutorials.